Triangulation is a geometric method used to measure the distance to an object by measuring the angles formed by a triangle. In the case of measuring celestial distances, the triangle is formed by 2 points on Earth and the object in question, such as a star or planet. By measuring the angles between the lines of sight to the object from the 2 points on Earth, astronomers can use trigonometry to calculate the distance to the object. The first recorded use of triangulation for measuring celestial distances dates back to the ancient Greeks, who used the method to estimate the distance to the Moon. By measuring the angle between the Sun and the Moon at the same time from 2 different locations on Earth, they were able to estimate the distance to the Moon as a fraction of the Earth's radius. In the 17th century, the astronomer Jean Piccard used triangulation to measure the distance to Mars. He observed the planet from 2 different locations in Paris, and used the resulting angle between the lines of sight to Mars to calculate its distance. This was the first successful attempt to measure the distance to a planet using triangulation. However, triangulation has limitations when it comes to measuring celestial distances. It only works for relatively nearby objects, as the angles involved become very small for more distant objects. Additionally, the Earth's atmosphere can distort the angles, making it difficult to obtain precise measurements. Despite these limitations, triangulation is still used in astronomy today, particularly for measuring the distance to the Moon and nearby planets. It is also used in conjunction with other methods, such as the parallax method, to improve the accuracy of distance measurements. Another method used for measuring celestial distances is the parallax method, which is based on the apparent shift in the position of a nearby object as seen from 2 different points. This method is particularly useful for measuring distances to stars within our own galaxy, as they are relatively close to us compared to objects in other galaxies. The parallax method works by observing the position of a star from 2 different points in space, the Earth at 2 different times, 6 months apart. As the Earth moves in its orbit, the apparent position of the star will appear to shift slightly against the more distant background of stars. This shift is called the parallax angle, and it can be measured using precision instruments. The distance to the star can be calculated using simple trigonometry, as the parallax angle is related to the distance of the star by a simple formula: distance equals 1, parallax angle. While the parallax method is a powerful tool for measuring distances to nearby stars, it has limitations. The accuracy of the measurements depends on the precision of the instruments used, and it becomes increasingly difficult to measure the parallax angle accurately for more distant stars. In fact, the parallax angle for most stars is so small that it can only be measured with the most sensitive telescopes and detectors. To overcome these limitations, astronomers have developed other techniques for measuring distances to more distant objects. For example, the cosmic distance ladder method uses a series of progressively more precise methods, such as using the brightness of stars called Cepheids to estimate distances to nearby galaxies, and then using the brightness and distribution of supernovae to estimate distances to more distant galaxies. The spectroscopic method is a powerful technique used by astronomers to measure distances to celestial objects. This method relies on the fact that each element and molecule in the star's atmosphere produces a unique set of spectral lines in the light it emits. By analyzing the spectrum of a star, astronomers can determine its chemical composition, temperature, and other properties. One of the key features of the spectroscopic method is that the spectra of stars can be used to determine their luminosity, or intrinsic brightness.